Okay, I'm tired, so this is the last one. It's going to be kind of simple. So this is a sorted list. It has key value pairs. It does a binary search. The key is the first thing. It can be any data type. That's can be any data type. It needs to be something comparable, probably, that you can compare to something else. To do an equals, see if it's the same thing. And then the second thing is the payload or the data. Sometimes this can seem arbitrary because you can work with the keys and you can work with the values. Either way, it just depends on how you implement it. But I've chosen the string to be the key and the double to be the value. So this is just a short, silly example of like keeping track of stock prices. Maybe the stock price for the day is stored in this thing, in this list. So the key is on the ticker symbol, and the value is a random value I just made up, right? I don't have the real data, so I just randomly made up a random double that's multiplied by 100. I think that'll give you up to 199 maybe. I can't remember how the math on that works, but it'll just kind of manipulate this random double to next double will give you a value between 0 and 1, not including 1, and then you multiply it to get like a value that you want in a certain range. Anyway, so I'll just add, what I'm doing is I'm adding these as the keys, and then just these as if these are the prices I want to know about. Then what you can do is search for that value in a list by using the key. So in this case I'm saying, hey, what is the value today of the stock price for IBM? What is the stock price for IBM? I use IBM as the key to find the value, and then that value is returned and added to this list box. So first I run it. A bunch of random things are when I click this button, a bunch of random values will be generated here and added under each one of these keys. And then it'll look for IBM here and return. It randomly generated 88 for IBM. So I think this will go up to, but not including 100 then maybe. Let's see if it's ever, yeah, that's 0 through 99.9, not non-repeating because that would be 100, so but infinitesimally close to 100.0. Anyway, you get the idea. So think of this as each time I click the button is a new day for IBM, and it goes wildly up and down. This is not like typical stock prices, right? They tend to be a little smoother than this. They don't jump around. That's another thing about randomness. You can't always use randomness to like model something like this. So if you look at the Tron, and I can't remember the term for it now, but I'll remember it in a minute. But like smooth randomness, like a mountain range, right? You don't have steeply up and down for mountains that like look like teeth or something. You want like gradually changing over. It could be very low at one end and very high at the other, but it gradually changes in between. Tron, there's a guy who came up with the algorithm for this, who did Tron, who won an Academy Award for it. I can't remember his name though, and I can't remember the thing that's named after him. So I'm going to pause and think. It's so frustrating. It's got to be because I'm tired though. I did just Google some words that brought me to it. Perlin Noise, Perlin, is the guy's name. He came up with the algorithm. Kim Perlin, in 1983, won an Oscar for it. So if I could institute some Perlin Noise in here, it wouldn't radically go from like 83 to, well, 99 is not very radical, but 35 from 99, that's a big drop. That's not very likely. You wanted it to go like 99, 97, 101, maybe 94, and you get the idea. And then gradually over time, maybe there's a decline. So 91, 90, 88, 84, right? That's Perlin Noise. Okay, that was a tangent, but it was a good way to end. Since this wasn't very long, just check out it looks like an array. That's kind of the thing you want to see. It is kind of an array. You would call it an associative array in other languages. So instead of an index here, you have a key, and it will look into this thing and find the thing at that key, which would be the value, and return it as if it were like a regular array. That ties up I am not doing another single lecture for chapter 8. Tomorrow I have to do date times and strings, and I don't want to do it because it's a lot. It's more work than I expect. I feel you guys. I sympathize because we're both like, I have to produce all the videos, which have never been done before because of the pandemic, and you guys have to do all the work. So we're in this together. If you have any questions, send me email.